if you look at the ASCII encoding, the limitations of the ASCII encoding. So how many characters? The ASCII encoding, the max number of characters it can hold is 127 characters. Only 127 characters. If you include 0, it's going to be 128 characters. But it's always 127. Because 0 doesn't have any value, right? It's all 0, 0, 0, 0, 0, 0, 0, 0, 0. If you represent that in 8 bits, am I right or wrong? So how many characters max you can represent? 127 characters. But just imagine the world, how it got evolved. So I can, first say, I can basically Telugu is also a language, Hindi is also a language, Urdu is also a language. There are several languages that came in, and you are seeing lots of emojis all these days, correct? Lots of emojis had come in. There are lots of symbols are being introduced in this computer evolution, correct? But can you fit in all those 127 in all those characters and all those symbols into 127? It's not possible, right? So ASCII is basically the American standard. So initially they thought, you guys know the typing machines, correct? The typing machines, I'm not sure how many of you really know it. Just need to put a paper into it and you start typing. It will keep coming up, correct? At the time when you look at the typing machines, most of the typing machines are just meant for, mostly all the letters are in English. You've taken all those characters from the typing machine and you had introduced this keyboard. So all the characters in the typing machine and in those days is basically all are represented in English. All of them are the English symbols, correct? The same typing machine they had took and they had built this keyboard. That means whatever the characters you see in the typing machine, most of the characters you'll see in your keyboard as well. All of them are the English symbols. But the world has evolved, right? You have Chinese characters, you have Telugu characters, you have Hindi characters, have lot meaning. But fitting all of them into with this 127 is not possible. So the limitations with the ASCII encoding is you cannot fit more than one, it has exactly 127 symbols. So if you, what about the text file that has the characters from the multiple languages? Okay, I know I had taken E, now I have a respective number which is a binary number, and now that is being converted into, sorry, I have a decimal number for it, now that can be easily converted into the binary. But when I take a Chinese character, does a Chinese character has any binary number mapping in your ASCII table? If I take Telugu character does that have a mapping in the ASCII table? Ultimately, it has to be converted into binary. Am I right or wrong? Then only, sorry, it has to convert it into a decimal. The decimal mapping should be there. It should exist. Am I right or wrong? Or else you cannot convert that into a binary. Am I right or wrong? So that's the reason why the limitation with the ASCII encoding is you have only 127 symbols in it. Not more than that. There are only 127 symbols. And those 127 symbols require how many bits? 8 bits, correct? 0 to 127, it's 8 bits. You take 127 and convert that into a binary, exactly take 8 bits. So don't need to worry, correct? So you take 8-bit representation, 2 to the power of 0, 2 to the power of 1, 2 squared, 2 cubed, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. Put all ones. And what is the number that you get after summing up that? It's going to be 127, as simple as it is. Are you guys following it? So, but 127 requires only 7 bits, and the last bit always be 0. That's what you guys need to understand. Okay. So now this is a limitation. So how to overcome this? So what is the solution for this? So that's where we have something called Unicode encoding. Okay. That's where we will be now looking into something called Unicodes. Okay. So now, what is an encoding, by the way? First of all, what is an encoding? We have been keep saying ASCII encoding, Unicode encoding. We have been keep talking about the encoding, correct? So what is an encoding first of all? The encoding basically means, according to the Google, encoding is similar to translating a message from one language to another. So it's more like message from one language to another so that it can be understood by someone who speaks at a different language. So as a humans, we understand human understandable language, but computers doesn't understand the human understandable language. All the computers understand is the binary language. So now you're converting the human understandable language into a binary language and storing that binary language in the computer's memory, and that's called as an encoding. Encoding is a technique of converting the human understandable language into a binary, as simple as it is. So anything for say, ASCII is also the same, correct? What is the ASCII doing? You have 127 symbols. Each symbol has a decimal number, and that you are converting into binary. That means when I type character A, capital letter A, the capital letter A is being given with the decimal number 65. Now that 65 is represented as binary inside your computer, as simple as it is. So now the limitation is you have only 127 characters. You cannot fit in all the universal symbols into it. So that's where the Unicode's encoding came into existence. So you are basically converting the number into the decimal from there to the binary, writing into the computer's memory, as simple as it is. You are taking a symbol, you are converting that into, and that will be mapped with decimal number, and that has been converted into binary, and that binary is stored in the computer's memory. And the reverse process is called decoding, as simple as it is. So that means you have a binary number. Now you are basically reading from the computer's memory, now converting that into a binary. Now you are representing the respective character or a symbol onto your screen. This is what happens internally. The moment I press type A, what will my keyboard do? Keyboard will go and look for the decimal number of that particular symbol that you pressed on, and the keyboard will take that decimal number, convert that into binary, and it will store that in computer's memory. Now computer has something called processor. Processor will take it and it will understand how to represent that inside the let's say you're trying to show that character onto the screen. It will basically try to represent that inside your memory in the form of a pixel. That means the pixel representation of that particular character inside your memory. Now the output device, which is a screen, will basically go and look at this location where this particular binary number exists. Then it will convert that back into the decimal number, and that will be represented as a symbol on your screen. This is what is happening. The moment I press A, immediately I could see A typing on my screen, right? How is it possible? So that fast your processors are. What is really happening the moment I press A or adding two decimal numbers? What is really happening? This much complex operations your CPU is basically performing just in a matter of microseconds. That fast your CPUs are. Go back to the traditional computing days. You have a complex computers. A computer would be in a size of this room, not even this room, maybe 2 rooms together. And you used to have something called punching cards. You just need to punch it. You need to give that. If you wanted to add 2 numbers, you will be having a punching card. You need to punch it. You need to feed it to the computer. It used to take 1 hour just to perform a simple addition. The punching cards is like, it's again, if you don't punch it, it is 1. If you punch it, it is a 0. Are you guys following what I'm saying? Punching card is like, it's like a OMR sheet, correct? You guys know how the OMR sheet look like? It's like you'll be seeing circles, correct? You will be filling it for the right answer. In the same way, when you fill that, that means when you punched it, that means that represents 1. If you don't punch it, that's all represented as zeros, as simple as it is. The old age of computing, when you have big computers, the computers of this room size, they used to have this punching card concept. So from there to here, just imagine where we are today. We are talking about large language models, chat GPTs, correct? Just imagine how the computer got evolved over the period of time. So you guys should need to know all these things. If you know all these things, when you write some programs, when you develop some programs, you will be more focused and conscious about using your memory and using your CPU. Ultimately, these are the two important components, correct? The memory and the CPU. How efficiently you use memory, how efficiently you use CPU. As simple as it is.